Hey, good morning, everybody. It's time for an Azure FunBytes get together here. Let's get started. Whoops. Okay, so hey, it's Jay. It's Monday, and I typically don't stream on Mondays, but I kind of felt like we could get a little something done together, and hopefully learn a little something for the beginning of the week. So, first of all, it's Monday. My setup isn't quite the same as it normally is back here, but that's okay because the big thing that we're going to do is, and I know with Azure FunBytes, typically I'm presenting you guests and working to kind of learn about some stuff, but I don't really end up doing a ton of the presentation. And so today I kind of felt like, hey, let's get together, and I've got some free time today. Let's go through some of the documentation that there is, and then build something. Okay. So we'll first start with this particular page, and I'll put it here into the the chat that we've got going. And if you have anything for me, please feel free to put some info in the chat. Let me know how you're doing. Tell me about what you got going on for your Monday. But this is what we've got going on. So I'm going to start with this quick start deploy an Azure Kubernetes cluster using the Azure CLI. And really, let's kind of get started with it. I think that this part on the top, says the most. And it's essentially AKS is a control plane for creating Kubernetes clusters on Azure. So rather than doing a lot of the upfront work of building those individual clusters, setting up monitoring, configuring all the things that you typically would need to do with a Kubernetes cluster, what we're going to do is utilize the service that Azure provides. So it's a platform as a service. And so rather than us doing all the work on our own, what are we going to do? We're going to get some help from Azure. And so here's what we're going to do first. We're going to deploy an AKS cluster using the Azure CLI. We're going to run a multi-container application with a web front end and an Redis instance. So Redis is great for caching small amounts of information. And then we're going to monitor the health of the cluster and pods that run your app. So here's some prerequisites. One, the Azure Bash shell, or Cloud Shell, I should say. You can do that in a couple different ways. You can use VS Code to manage that and the work that you're going to do in there. You can use the Cloud Shell based in Azure. So you can just go to shell.azure.com and it'll give you a working Bash shell. You can also use PowerShell. Both of them are great. Or you could use the portal, but today we're going to stick with the Azure Cloud Shell. It's really, for my money, and I'm not spending anything because I am cloud privileged because I work for Azure. For my money, it's the easiest way. And so let's get started. Now, the first thing we're going to do is we're going to create a resource group. And simply stated, I like to think of a resource group almost like a carton for eggs. When we put eggs in a carton, we look at it as we can take an egg out, we can put it in. If there's an egg that actually breaks by accident within the carton, we don't necessarily have to do something like, throw away everything. We can just pull out that one egg and replace it. And if we have more than one egg carton, we can actually take our eggs and put it from one egg carton to the other. So the egg carton is our resource group. The eggs inside of it are our actual resources. And then from there, what we can do, obviously, is if we need to, and let's say we don't want these eggs, they're old, something like that, we can take the whole egg carton and just throw it away. So to get started, we're going to just copy this, and it's AZ group create name resource group location East US. So what does that mean? We're going to create a resource group called my resource group, and we're going to put it in the East US region. So let's go ahead and just paste that in here. It only really takes a second. These are like one of the easiest things that you can do here in Azure, just creating resource groups. They happen pretty quickly. So let's take a look at what came out. So what we do is we actually have an ID. This is kind of like our subscription unique identifier, UUID. What exactly, when we're doing from the API, we're going and we're working with resource groups, and then we're calling it my resource group. So this is kind of like a URI. Then we have here the location. We picked East US. Managed by, no, I didn't set the managed by. This is a demo. Name, my resource group. Properties, it's in provisioned. The tags, they're set to null. And the type, well, it's a resource group. So tags, let's talk about that really quickly. If we want to add some more organization, let's go in here. We'll go to my resource groups right here. So everything that happens in the portal, we can get information. So let's refresh. Where is it? We created it. Where is it? Let's try it. See, that's what happens when you do these things live. So let's see. AZ show groups, or I should say AZ group show. And we have to give the name. So we'll go G and we'll go my resource group. Okay, it shows it's there. Maybe interface is just a little slow. Let's see. Define my resource group. Peculiar. So then the best thing I can do is make sure it should be under this subscription. This is the default subscription I have set. It's always fun to do these things live, which I am. I'm live on all these streaming services. And as you can see, what I'm looking for isn't there. That's really weird. We can see, though, it was created. Let me just double check that this is my subscription ID right here. Let's view my directories. So yeah, that's my directory. Yeah, that's all set. Weird. Must be some sort of UI bug. Whatever. We'll keep going. So we've created our resource group, and now the next step. Of course, when we did that, we got our JSON that provided us some details on what happened. So now we're going to enable cluster monitoring. So we need to basically just turn on some registrations for some services in Azure. And what we can do, just copy and paste these into here. And it'll go ahead and it'll turn them on. So now these operations management and operational insights, these services are now enabled for my account. So that's my subscription. So the next step, what we want to do, let's see. Let's actually register them. So the first one is to show that, and the second one is to register. Now I'm already registered on these services, but all I need to do is I can run them. It's not going to make a difference. It's idempotent. So it runs once. If you run it again, it's no big deal. So the next thing we're going to do is we're going to create our Kubernetes cluster. And let's take a look at this command. Let's do that. So I'm just going to put it in code for a second so that we can look at the command. And that's one of the great things about using code here in the Azure portal, is that you get kind of like a mini version of VS Code that you can work with. So let's see what we're creating. It's going to go AZ create the resource group that we just created, my resource group. The name of the cluster is going to be my AKS cluster. The node count, which is going to be one node. But you know what? I think you can go ahead and start with 3. It would probably be preferred that you start with 3, but because this is a demo, we're just going to work with this. So now we're going to enable add-ons for monitoring, and then we're going to generate our SSH keys. So let's go ahead and close this. Oop, we can just go back to shell. Let's go back into the shell where we were for working on our, and let's take a look and see if our resource group is visible now. All right. So here are all the resource groups and all the different subscriptions that I have access to. We'll just go to mine. Okay, yeah, it looks like there's an Azure Monitor issue right now. Might be one of the reasons why we're running into some of these issues, but they're investigating it. Hey, it happens. So let's create this cluster. So we'll copy this. We'll go to the Azure shell. So we can go to shell.azure.com. This will bring up the full screen version of the Azure Cloud Shell. Let's pull this up. Just taking a minute, no big deal. Could be related to our little issues that we're seeing right now, but who knows? Let's restart it just to be sure. All right, so now it's going to restart the Cloud Shell. So it's just going to kind of restart the little image that it's connected to, and then mount my storage. And that storage is just a blob that contains all the files that are part of my Cloud Shell. I keep lots and lots of files in my Cloud Shell account. So if I need to do something like clone a repository, SSH keys, they're all there. Let's take a second and figure out what's going on here. We may be running. I might have started the stream and then all of a sudden some resource issues are starting to happen, which means we may have to cut this short. That would really stink because I was really hoping to show you all some stuff. Let's wait it out a second and see what happens, okay? Okay, there we go. There's our shell. We've got the shell. So let's go ahead and let's grab that create AKS cluster command. And what we'll do is we'll go ahead and paste it in here. Come on. Copy. Got it. Looks like we're having some issues doing that. That sucks. Well, sometimes when you do these things, yep, see, we're having some service issues today. I'll try doing this again if I can't get this running, maybe later today or tomorrow. Just because I'd really like to work with you on this. And unfortunately, things are not really going in my favor. But hey, let's see. It's requesting a terminal. Let's see if this goes. In the meantime, let's also remember that there's some really cool AzureFunBytes episodes coming up soon. This week, we're going to do, the next 2 weeks, actually, we're going to work on Data Factory. So I've got some people from the Data Factory product team. They're going to come and help me out. Okay, great. There's my Cloud Shell. So let's paste that command. So here we are. It's AZAKS, so AZ is the actual Azure CLI. AKS, which is the sub command that we want to use. Create, and then it's going to specify we want to create it in our resource group. We want to call it my AKS cluster. We want to have one node, and then we're going to enable these add-ons. And then we're going to generate SSH keys so we can actually get into our cluster. So right now, what's going on is that this information is going over to the Azure Resource Manager. And the Azure Resource Manager is essentially saying, hey, Jay wants to build a resource, an AKS cluster, and he wants to put it in resource group, my resource group. Makes a lot of sense. It's just another control plane. It gives you some ability to manage your Azure account back and forth, whatever you need to do, updates, edits. It's a singular control plane. It's got a bunch of different ways to work with it. The CLI tools. There's also the portal like we see here. And so if we create, anything here, it's essentially going through the Azure Resource Manager. If we go into one of our deployments, and you can see, let me close this. Here in my deployment, I've got some resources already created. I can actually export these into a template, and we can use what's known as an ARM template, an Azure Resource Manager template, to create our resources. And we can use that template in a browser command. We can use it alongside the Azure CLI. So it's a really powerful way of manipulating your Azure account. So right now, we are still building. And what is this doing underneath? Well, the first thing it's going to try to do is provision a node. And so that's going to be just a virtual machine that it's going to create. And in that virtual machine, it's going to actually set up all the requirements around Kubernetes. And what we'll do is once this is up and running, we're going to then get the credentials from the AZ command and be able to log into our Kubernetes clusters, take a look at what exactly it is installed, and then eventually create the new resources we want to have that voting app. So we'll look along, and what we're going to see here is the connect to cluster piece. And kube control or kubectl, however you want to pronounce it, is the CLI utility to actually work along with Kubernetes. So if you want to make changes to Kubernetes, you would do it all through this kubectl command. You can install it locally. It's available in the Cloud Shell. And so when I mentioned before getting the credentials, what's going to happen is I'm going to run that AZAKS get credentials command. And then that get credentials command is actually going to import the credential file and put it into a local resource file so that we can just keep it in our shell. And then when we need to access kubectl, won't have to actually ask us for our authentication method every single time. It's kind of cached into the shell, and you'll be able to work from there. So let's take a look at our resource groups, see what's going on. Oh, there it is. Just took a little while. So there's my resource group, and you can see right here, my AKS cluster is being built. And then once we go in here, we can see all kind of the basics while it's being created. So we created a version that's 1.19.9. We'll talk about why that's important. You can integrate Azure Active Directory. So if you want to have specific users via AD that are authenticated to be able to make your changes, you can do it that way. Here's the actual node size. So it's using a standard DS2 v2 underlying node for the VM. So that's where all of our virtual machine information will be stored, or I should say that's our virtual machine. Here's some of our networking info. So we've got our Docker bridge CIDR, a DNS service that manages local DNS within the cluster, the actual service subnet, the pod subnet, so the IP addresses that are available. Then there's the integrations. We enable container insights. And we'll take a look at that once we actually start building and working. So you'll see node pools here. And this is an important part because this is where we can actually start some of our hardware-based scaling. So not like our pod scaling. So pods will let us, start individual containers for different services. But when we're working with the node, the node is actually where the pods are living along with the rest of the items of Kubernetes. So that's done. Okay, our cluster's built. And just like when we created our resource group, we've got our everything in JSON, or I should say, I guess this is a JSON format. Everything comes out in JSON with all the information about our cluster. So let's get on to the next step. So we want to install kubectl. We don't need to. I've already done it. But if you want to, you can run this command, AZAKS install CLI. That'll get kubectl. And now we are going to use kubectl to get our credentials. So AZAKS get credentials. This command makes using AKS super flexible. And the reason why I say that is that no matter where I am, I can have access to my Kubernetes cluster resources. I don't need to worry about knowing where credentials are. They're there. So we can just download them and get them whenever we need it. So AZAKS get credentials. Resource group is my resource group, and the name is my AKS cluster. So let's go ahead. And now you can see the merged my AKS cluster as the current context. And this is the config file for Kubernetes that will be used for kubectl. So let's do something really simple. Let me pull this up to full. So let's start with the most basic thing that we can do before we kind of get into the rest of our demo. First, what we can do is just do kubectl get nodes, and that will kind of mimic that portion inside the portal where we actually saw the nodes that are underneath in our cluster. So you can see here AKS node pool 1, which is the name of the VM, and then some unique identifiers. The status is ready, the roles are agent, this is how long age, how long it's been online, and then the version of Kubernetes that's installed. And so we can do some other things like kubectl get pods. This is the pods that will be created. We've not created any pods yet. Get service. These are the services that have been created. So here's our cluster IP. This is where we're making API calls to what is in Kubernetes. All right, cool. So let's go to the next portion of our demo. And what we did this kubectl get nodes. We found out what nodes we're running. And so next, what we're going to do is start actually applying an application. And so what we are told to do here is to create a file. So I'm just going to copy that file name. Let's code and the file, azure.vote or azure-vote.yaml. And now it'll create a new file for us. And what we're going to do is use this YAML definition. And this is essentially a set of instructions of how we want to create the services that are going to be on our Kubernetes cluster. And so what we're going to do, as you can see here, let's go through a little bit one at a time. We're going to create a deployment. Its name is going to be Azure Vote Back. We're going to have it on one replica, so it's going to only be in one pod. And then what we're going to do is create a container based on this public image. If I wanted, I can create a private image, and I can show you how to do that in a little bit. We can allow this empty password because we're not going to be grabbing a password to work with this. And then we're actually going to give some auto-scaling resource information. So we're going to say what CPU maximum limits here, memory that we want. Then we're going to say what ports Redis is going to be running on. And here it is. It's 6379. And so we can go continue this, and now we're going to get another. So that's kind of like the back end portion, because you see it's called Azure Vote Back. That's the back end of our application. Now we're going to also, in the same file, build our front end, an Azure Vote Front. And that's going to do kind of the same thing. It's going to go in here. It's going to grab the image of what we're going to be working with. We're going to then connect to the backend, name Redis here. And then finally, what we're going to do is we're going to create a load balancer. And so what's that load balancer going to do? It's actually going to serve with a public IP our application. So let's go ahead and let's copy the contents of this file. Let's go back to our shell, and I've pasted them in. Very cool. We've got everything here we need. And we can do things if we wanted to, like we could change replicas to 3, just leave it at 1. The same thing for the front end. So if we wanted to add some redundancy, we could. So let's go ahead and save the file. Let's close the editor. And so now what I'm going to do is I'll ls, just to show you it's there, AzureVote.yaml. There's the file. It's here in my Cloud Shell. I could do this from a local environment if I wanted to. I don't have to use the Cloud Shell. I could just install the AZ command inside of my local computer. I could use a VM. It doesn't really matter. It's as long as you're authenticated, and that's all you really need to do. So what are we going to do next? We're going to do kubectl apply -f, which is the file Azure Vote. So what we're basically doing is we're telling it to apply the instructions that are contained within that YAML file. So let's go ahead and paste that in. We'll hit enter. And so kubectl spits out, I've created your deployment, I've created the service, and that's for our back end. And then it does the front for our front end, or it does the same for our front end. So let's take a look. So we can do kubectl get pods watch, which means we'll watch it being created. And so right now you can see Kubernetes is creating our containers that is going to be hosting these 2 different services. So our front end service is already up, and there's our back end service. So they're both online. And we also included the need for a load balancer here. And to take a look at that, we can just type kubectl get service. And what you can see right here is the service with a public IP that Azure has provided. So just do a quick curl here. You can see it's already online. Let's go into it. And now we have our voting app. It's online. It's ready to go. I'm a dogs person. If you want to vote, here is the IP address in the chat. If you're watching a recording of this, sorry, it's not going to work. But go ahead and vote on whether you're cats or dogs. And if you're watching and you're in the chat right now, why don't you say hello? Let me know that you're digging this if you are. If you're not, I can always tweak it. And of course, one of the things that we're going to work with as a kind of after effect is that little bit of issue with monitoring. But we'll take a look and we'll see what we can find is going on. So let's go back into this my AKS cluster. This is all online. And so what I want you to do is to take a look at some of the visualization that's in the Azure portal for the resources we just created. And so everything that you create in Kubernetes lives within a namespace. It's a place to actually keep all the different deployments we create. And I just used the default namespace when I created that. So if I click default, we'll just get a little bit of information. We'll click see more, not much here. We can look at the YAML. The YAML will give us some information about what's in here in the default. It'll give us events of what's going on. So this is great for auditing, for monitoring, for logging, finding out what you've been doing. Then we've got our node lease, our kube public, and our kube system, the services that are managing their cluster. And then now we can take a look at workloads and we can see the different things that are running. And here are the 2 services. Core DNS is running our DNS server. And right here we see Azure Vote Back, Azure Vote Front. We can go ahead and click on one of those and we get some information, including the pod that's been created right here. So we can click on that pod. And that pod will give you its template hash, where its node selector is, and its creation time. So when we actually made it, how it was, what its control the replica set, the node that it lives on, the IP address, that's the private IP that's eventually natted back to get to the front end. That's in the case of the front side. But anyhow, we've created all that. Let's go back. Services and ingresses. Here you can see the actual methods to connect to these different services that we've created. So the back end has this cluster IP. That IP is contacted by the load balancer or I should say, by the front end service to actually store everything in Redis. And then we've got the public IP that serves that front end. All right. Let's go over to storage. And so we don't have any persistent volumes that are connected to our cluster. If we wanted to, we can click connect. We can copy a YAML file from the walkthrough from a sample app that'll actually create some storage for us. And so this is what we've been working on. So let's go to the next part of going. So we tested the application and we've actually worked. So we worked through this entire module right here. And you can do this yourself if you want. There's a bunch of other tutorials. You can prepare an application. So this allows you to actually create the container images that are required. So let's get to a little bit around creating more resources. And one of the things that I love to do is I like to script things so that they happen a little faster. And so what I did was I have a way that what we're going to do is create an Azure Kubernetes service. We're going to create an Azure Container Service, and we're going to connect them via service principal. And I think that this is something that if you want to work with Kubernetes, you can create this pretty quickly. So it's as simple as this. What you do is you just go to code, grab the repository, location. Let's go here, my dashboard. So let's just do make dir new any whatever cd any. Okay, so let's git clone our repo. And so that's going to clone this all-in-one script. And I will put this all-in-one repo here in the chat. There you go. For those of you who may be watching on a recorded, there's the location of the script that we're going to be working on. So what we'll do is let's see what's here, AKS all-in-one. Now let's open up AKS ACR. We'll do it actually in code so I don't show you all my VI nonsense. And so right now what we need to do is just add some resource variables. First thing we're going to do is we're going to create a group. Like we talked about before, a resource group. We'll call it FB Monday. So we're going to create a resource group and call it FB Monday. Next, we're going to create a location, East US. That's the closest to me. That's where our resources are going to be located. Now, what we're going to do is create our Azure Kubernetes Service cluster. We're going to give it a name. And so I'll just call it, let's say, FB Monday AKS. We're going to give an ACR, the Azure Container Registry. And what is that? That's a place to keep our images. So if we want to actually create our own images rather than use public ones, we can create an ACR. And that ACR will store our images. It's globally replicated. It's a really useful service. So what I'll do is I'll just create a cluster here or ACR, and I'll call it FB Monday ACR. And then my subscription ID, which I can get if I go to view my account, I believe. Actually, no. What I'm going to do is go to subscriptions here in the tab. And right here is my subscription ID for the sub that I'm using. And so I'll go ahead, I'll copy this, and I can just paste it here into sub ID. And so now there's just one more variable I need to fill out, and that is the version of Kubernetes I want to use. And so let's take a look at all the available versions that we have in the location I'm in. So what I can do is just copy this variable, paste it into my shell, and then run this command right here, aks get versions, the location, and then I output it in a format that's a little bit more human readable. So I hit enter here, and now what you can see are all the versions of Kubernetes and what you can upgrade to from the version you select. So it's kind of like you're stepping forward. So if I download, or if I use 1.18.14, I'll be able to upgrade to these 1.18.17, 1.19.7, 1.19.19. And then once I'm on those versions, I can step up all the way to 1.25. So let's pick one. Let's so we can show an upgrade at one point. Let's show 1.18.17. Go ahead and paste that in here. And so what's going to happen next is it's going to use this command to create a service principal. That's a way of using Azure Active Directory to connect our service principal. Then what we're going to do is just going to save our app ID and our password that we've created as variables. We'll echo them out so we can see them. Hey, thank you. I hope you're well too. It's still morning here, but I appreciate it. And then what we'll do is we'll create the cluster here. All right. I could copy and paste all of this if I really wanted to, line by line. So let's do that. All right. So the first thing we'll do here is store these variables in the shell. So I've stored all these variables. These are the group name, the location, the AKS cluster, the ACR, the sub ID that we're going to be creating. Next, we're going to set another variable of the version of Kubernetes that we're going to be using, and that's 1.18.17. So next, what I'm going to do is I'm going to create that service principal. So it's a username and a password. And if I go ahead and I paste it into here, it'll start the process of creating for role-based authentication, the credentials I need. It did not output them to the front. What we're going to do is we're going to get them out of that temp file because I've stored them in a temp file. And so we can go ahead and actually look here. And they've been stored as variables within Bash. So I can echo the variables themselves if I wanted to. Like if I wanted to do echo location East US, that's the variable that I set. So now let's create the resource group. There's the resource group that we've created. We called it FB Monday. We created East US. It's on my subscription. Now we're going to go ahead and create the Kubernetes cluster. And so we can see I've got some monitoring, some HTTP application routing enabled. I state the version of Kubernetes. And then when I create it, the thing that's different about the cluster we created the first time around, let's take a look at it, is that I am specifying a service principal, app ID, and password so that that's basically enabled for our Kubernetes cluster. So let's go ahead, copy those, paste that in here, hit enter. And so now all of my requested resources are going to be started to be created by the Azure Resource Manager. All right, cool. And so once this is done, what we're going to do is we're going to get the credentials. Okay. And then once that's finished, what we're going to do is we're going to connect our Azure Container Registry via that role-based authentication using Azure AD as the underlying service to allow it to actually pull container images from it so we can actually run them in Kubernetes. So this will take a couple minutes. This is actually because I didn't specify the number of nodes that I want. It's actually going to create it with 3 nodes. So that's right. My Kubernetes cluster is in Azure. That's correct. That's where I'm creating it. Let's see if we refresh here. There's FB Monday. Here's our FB Monday AKS cluster we've created. And so like I showed you before, the difference here is if we go into node pools, you'll see that it's creating node pool 1 and it has a node count of 3. And what we can do here is one of 2 choices. We can manually scale up. So let's say I've done really well. I've put up my service and it's whether it's a web service or an API or something like that, and people love it. And I need more resources, more hardware. I can always auto scale based on utilization. So I can pick the number of CPUs I need there, or I can just manually scale it. The max pods that are allowed on a node, so the number of containers that can be run on a single node, is about 110. And it's using the standard DS2 V2. I could have actually picked a different hardware type if I wanted to when I did the create command, but I because we've got other node pool types available. So let's take a look at that. So what I can actually do is use different types of CPUs. We can pick Linux. If I had Windows authentication available, I could have used that. So let's go to node size. And you can see that there are all these different types of hardware types that we could use. So if I need just standard, I can use the DS. If I need high performance VMs, we've got the H series. We've even got, let me see, I think we have some GPUs and things like that you can utilize. So if you need to do something specific, let's say, I don't know, there you go, like here's some NVIDIA. So if you need to do some big data crunching and you want to do it via Kubernetes, you can specify you want to use these GPU nodes. So let's see how our cluster build is doing. Still going. It'll be ready in just a few minutes. So we can, if we wanted to increase our node pool or have a multiple node pools that are all managed within the same Kubernetes cluster, we could do that. We can take a look at the cluster configuration. We'll upgrade our version at some point. AKS managed Azure directory. If we want to enable, we can configure role-based authentication using Azure AD group membership. This can be used to control access to specific namespaces inside your Kubernetes cluster. I think this is another useful service that you can enable to add a little bit more control, put up some more gates if you have governance. Scale here. We showed you that. I'll never understand why this little scale icon is there because it doesn't really do anything, but there it is. Networking, so we can take a look at the networking information. We can set authorized API access through certain ranges. We can enable an ingress controller if we need to. We've also got policies that we can set. So onboard to Azure policy which is its own service for Kubernetes. We've got monitoring, so app insights, so we can get information on how our clusters are actually doing. Because we have not completed our cluster creation, we don't really have anything here yet. All right, so our cluster is done being created. Now we're going to just grab the credentials. So it's just like when we started the first time around. Now I've got my cluster credentials. Great. So that FB Monday AKS cluster, that's over here now in my local context. So if I wanted to, I can do kubectl get nodes. And what we'll do is we'll see, as compared to the last cluster we created, we've got 3 nodes and we've got version 1.18.17. All right. So now I mentioned what we want to do is actually have have a place to keep our containers. And so right here, we're going to do AZACR create. I'll show you the ACR portal after we actually create this using the CLI. So we'll specify the subscription, the resource group we want it to be in, the name that we set as a variable, the SKU, standard if we needed. There's other SKUs with at higher prices to do more things. And then admin enable true. So what we can do is if we want to use Docker to log in, we can use a username and password. So let's do that AZACR create. It should just happen pretty fast. There you go. So now our container registry is created. Let's take a look at it. So let's go into our resource group, refresh this. Sometimes it just takes a second. It'll be there. Well, while that's populating in the portal, we'll do the next step. So we're going to create the RBAC, the role-based authentication for Azure AD to permit build and pull from the Azure Container Registry to the AKS cluster. And so first of all, we're going to get that service principal ID. Okay. Then we're going to get the registry of our resource ID. So AZACR, the resource ID. We'll paste this in. And now what we'll do is we'll create a role assignment. So we're going to create the role assignment ACR pull. Let's take a look at that in our docs. So there's some built-in roles within Azure on what they do. An ACR pull allows you to pull artifacts from a container registry. And it's got this unique identifier associated with the service. So that's the ID for it. Okay, so let's go here. There we go. Now here's our ACR. We can take a look at it from the portal. We can see how much storage is available, how much storage is used, which is none. We can see the different tasks that are capable of being done. So we can build, run, push, and patch containers. We can integrate Aqua Security, so we can actually do some vulnerability checks against our containers. There's some other stuff here that we can look at, like the access key for the credentials. Don't worry if you see them, because this won't be available to use by the time I am finished. There's identity, so we can have user controlled or system controlled identity services. And then within here will be the repositories that we actually create to store our images. Okay. All right. So let's go back to the next part of our script. And let's see what we're going to do next. So we've connected everything. We've looked at our nodes, so we're ready to rock. We can start using our AKS cluster. And so there's a few things we could do to deploy. I am going to show you how to deploy via one of the most simple services that it allows you to do actual code deployments to our AKS cluster. So I'm going to go into the resource group. I'm going to pick the Kubernetes cluster, and then I'm going to go to this service called Deployment Center. I love Deployment Center because it simplifies the process of actually doing your deployments, because it allows you to use good process. And in this case, we're using a CI/CD process, continuous integration, continuous deployment. And we're going to be able to use these different services, Azure repos if you're using Azure DevOps, GitHub and GitHub Actions, which we'll use today, Bitbucket, or if you have an external Git within your company, or you have a private Git, you can use that. So I'm just going to click Next. And so right now it's going to need to authorize my GitHub account. I click Authorize. I've already authenticated, and so it just pulled up a pop-up and re-authenticated for me. If this is the first time you've done that, what it'll actually do is it'll have you log into your GitHub account. If you need to do two-factor, it'll do that. And so we have the ability to pick my repositories or all repositories. We're just going to be working with my repositories. And what we've got are a few services or a few apps that I've got here. And I'm going to just use this demo app. And then we're going to make some changes so we can actually get it online. So this is going to just create some default stuff, some default YAML. It's going to apply that default YAML to our Kubernetes cluster and get us online. So let's go ahead. It's going to go to the master branch. We'll click next. It's going to analyze. It's going to find a Docker file and see exactly what's going to be done. So it's going to be using the Node 8 runtime. It's going to be using a user source app as its work directory. It's going to copy this package. It'll do an npm install of our app. It'll copy over into our production area, and then it'll start and expose port 8000. Okay. So let's just click next. And so what we're going to do is we're going to select what namespace we want to put this in. I'm just going to use the default namespace, but if we wanted to separate everything and have multiple installations of different applications on the same cluster, we can specify a namespace for each. I'm just going to use default. And then we can specify the container registry where the actual image that's going to be created from code is going to be stored. So we're going to pick the one we created, which is FBA Monday ACR. We'll click done. And so now it's going to actually configure the CI/CD process. So it's going to set up everything on the GitHub side for us. I don't have to write this YAML pipeline right here. And so let's take a look at it. We can see right here, we're adding a workflow file. And it kicks off a build process in GitHub Actions. So GitHub Actions is a CI/CD service as a service within GitHub, allowing you to do builds and deploys. We can look at the log of what's going on, sets up the job. It knows to start running this action based on a trigger whenever there is a production commit. We can then see that it logs into the Docker and starts the process of actually now creating our container image. So it'll pull the required resources, the base image, and then what it'll do is build the image with our code and the dependencies. And in this case, our dependency is Node.js. And so we'll see now it's built. Now it's being pushed up to our container registry. You can see that's literally the name of this function, build and push image to ACR. So you can do this stuff manually if you want to. And you don't necessarily need to do it through the deployment center. If you really wanted to, let's take a look. And this is, like I said, it's just a simple demo app that I've created. There's not much to it. You can go and you can see I've created these Kubernetes files. And these are the YAML files that we can just specify and actually execute manually. The only thing I would have to do is change the name of my ACR right here. So rather than ACR here, I would change it to the ACR that I created. So FB Monday ACR. And then the version of the application that we've created. We could have built that container manually by hand, but I decided to let Azure and GitHub Actions do it for me. So we've actually finished everything. So we see we built and pushed our image to the ACR. Now we've actually applied some of our new changes. So you can see it's just using kubectl. It's scripting kubectl commands. And then adding some variables. It's creating a secret between the container registry and the actual place where we're going to be connecting to and then putting it into our image. So we've got our credentials here. We don't need to concern ourselves with them. We've got our created as a secret. Now we've started our deploy process. And so you can see it starts deploying our clusters, new files into the namespace default. And so we've created the three I should say the three services: the deployment, the service, and then the ingress. And then finally, you can see it's finished. We get some output telling us that everything is built and created, deployed. Then there's some post run where it starts cleaning things up, and then that's that. And as you can see, as they say in Ghostbusters, the light is green, the trap is clean. Our CI/CD process worked. So to validate what's going on, what we can do is type kubectl, it's pods, and that'll use the default namespace, which is what we used. And you can see I've got 2 pods running with our app on them. And then what we can do here is kubectl get service. Now, we don't have a public IP available. And that's because what we did was we created in the automated service just a cluster IP. And so let's show you what a cluster IP is versus a load balancer. We'll go to the docs. Cluster IP is the service for default. It gives you a service inside your cluster that other apps inside your clusters can connect to. So it's really useful for an internal API. Let's take a look. Traffic goes through the proxy, then it gets routed to the service, and then the service routes it to the individual pods with our images on them. So if we take a look, what we can start doing is making some changes to the files that actually GitHub Actions created. So if you go here into code, what you'll see is GitHub Actions has this default working YAML file that was created by the deployment center. And you can see that some variables, the secrets to actually log in to our ACR, the process of building that image. So all the things that we saw before, then create a secret, then deploy, and you can see these 3 files here: manifest, service, ingress. So, or I should say deployment, service, ingress. So let's take a look at those files, okay? So those were actually created, and I'll show you something that's really cool, is that I love that Azure goes ahead and creates a secret for us that allows it to connect back and forth to the different resources we have. I don't have to go in here and provide keys. Azure does that for us. It automates the process. It stores secrets here within GitHub and allows GitHub Actions eventually to set those as those variables and connect to our ACR, and then pull the container image to the ACR, or I should say from the ACR into the AKS cluster. Sorry about my mumble mouth. All right, so the next thing I want to show you is there are those manifests that we created. And I have some ones that I created already for this cluster. And this is one for a load balancer. And you can see all this load balancer does is very simply uses a protocol TCP and goes the target port of 8000 to the port 80. So let's take a look at the manifests that the deployment center created for us, though. So we go here to manifests. We can see deployment. And this is actually just creating the deployment itself, the containers that we want, the image that container is going to run on, and then the port that it wants to present. And that'll have a private IP. The service here, that's for our cluster API. We can see the port, the target port, that's all internal, and then ingress. And so ingress is the one that I'm going to make a little bit of a change on. Actually, we don't need, now that I think about it, here in service, we don't need this to be a cluster API because we actually need it to be presented. It's just a demo app. And so what I'm going to do here is I'm going to edit this file live. All right. So let's go in here and let's just make a few changes. Let's change the cluster type to load balancer. And then our port is going to be 80 and our target port, it'll be 8,000. So that's the port it'll be able to access to present our application to port 80. All right. So let's go ahead and commit these changes. And so we'll commit the changes. You shouldn't commit directly to master, but this is demo. And once I do that, so when you create that CI/CD process, it allows for all future changes to be kicked off every single time you push to that branch. And so now we've gone ahead and we've kicked off that new build process. So what is it going to do? It's going to go through everything again. It's going to go ahead and update the image. After it updates the image, it'll do the build process. So this will make sure that any of the changes that you make, they're always going to go through and they're going to work. And if it doesn't work, then AKS will fail. Or I should say that the ACR to AKS deploy process will fail. So if there's something wrong with your tests that you've added, something doesn't work properly, you can go ahead and not deploy it directly and have a broken commit within your application that's live in production. We don't want to do that. So now it's going to go ahead and it's going to deploy our change. It's going to make that quick change to the manifest file that allows us to present to port 80. And so what I want you to see now, so you can see here these were set as a cluster IP and then the Kubernetes API. Now I want to do this again. So let's do kubectl get service. And that's going to ask for the services. And now you can see that cluster IP changed over to a load balancer. And I could do both if I really needed to, but I don't need a cluster IP because I'm not doing any internal access. And so if I go ahead and I copy this IP and curl it, hello world, put it in the browser, hello world, and it's a little tiny. That's all this app does. This app just does a hello world. And the reason why is that if I want to present a more complex app, I will. But for those who are just getting started, this really is the basics. So I showed you how to make some changes to Kubernetes. Now let's just modify this hello world. I think that's probably the easiest next kind of step to show in here. So let's go back to code. And let's go into app.js. So now what we want to do is actually make a change to the app. And in this case, we're going to see it's a super simple Express application. If I go and I click the pencil, I can actually change what it's printing in the hello world. So right now it says hello world right here. I am making changes. Okay, cool. So what I've done is I've gone ahead and I've created a change. Now, if I wanted to, I can create a new branch, update J, updating code, and then propose this change. All right. So now we'll create a PR. If you were in a regular kind of working environment, what we can do is have this wait till we actually merge. So let's merge this pull request, confirm the merge. And now if we go back to our actions file here, we'll see that we've merged in this. So it'll run a test to make sure that what we're doing is working. And then what it'll do is it'll actually merge the pull request in and eventually make our change. So once again, GitHub Actions doing all the heavy lifting. All we have to do is update what's in that repo. And every single time we update what's in that repo, there's a new triggered action. Or I should say there's a new trigger that goes to Actions, and Action says, all right, I've got some work to do. Someone just shared with me the fact that there's a change. All right. So we'll let it run through the process of all the stuff. It'll create a new container image with the change to our code. So if it was more complex than just like a single line, it would go through the whole process like this of building the container image, updating any dependencies if you have them. If you have tests, rerunning the tests to make sure everything works. All right, lights green, trap's clean. Let's go ahead, scroll that IP address. Hello world, I'm making a change. There we are. So you can see our change was applied. All I had to do was go into the GitHub portal and just tap, tap, tap. Anyway, that's really it for today. Let's clean up our resources. It's always good to clean up your mess. So let's delete the resource group, okay? So AZ group delete. What did I call it? You can do it from the portal, but I'm going to do it from here just to kind of keep everything CLI centric. So the name of the resource group, and this is our carton of eggs. We're going to throw out our entire carton of eggs and everything that's within it. So we'll just call it name Monday. And then we'll say yes. And then it'll start deleting the resource group, all the resources that are inside of it. And that's really it. So I've given you some resources to work with. I'll put them in the notes that are going to be on YouTube. But if you want to use that AKS ACR script that I have, I've got all the information right here. If you want to use this simple ABC demo app, I've got that for you. That app that basically it's just there for you to kind of futz around with and have a getting started place. You can go with more complex applications to do more complex things, but in this case, I just want you to have a hello world. All right. And let's take a look. This will take a little bit, but that's everything. All right. So I'm going to pull this out. Now I'll just be. Anyway, I really enjoyed helping you out, showing you a little Kubernetes today. If you have any questions, you can always find me at jdestro on Twitter. And, I think that you're going to have success with Kubernetes. Just use a lot of the documentation, try some of the tutorials, and, hopefully you see it's as easy as I do. So that's really it. Why don't you watch this, and then we'll say goodbye.
Why should I choose a container over a full operating system? In years of working in the world of operations and deployment, I've thought about the complexity that goes behind managing operating systems. And let me tell you, between storage, between all the patching, security, network intrusions, you name it, it's just a lot more work. If you're simply needing a runtime to have your application run, there's no need for you to run an entire operating system, manage a kernel, and ensure all those other extra packages are managed. Let's move beyond that. Let's simplify life. A container will just provide you with the runtime you may need, and then you can go ahead, add any additional dependencies, and then make sure your application runs. So it's about reducing how much work you as a developer or maybe an operations person have to do, and really improving how quickly you can work. So less mess, less fuss, and more creating. And that's really the big key. We say containers over maybe a full virtual machine because it's going to give you the added control, simplicity, and ultimately the ease of deployment for your application.